Hello, welcome to our presentation on CantonMT, Cantonese to English neural machine translation platform with fine-tuned models using real and synthetic back translation data. It's a collaborative work with Huang, myself, Riza, and Goran. We have our GitHub page with our trained models that people can use for research purpose, free of charge. So I will introduce the motivation, the data and the model, methodologies, evaluation, and our demo. Firstly, Cantonese is one of the most popular dialects of Chinese languages. The origin of Cantonese is from Guangdong province. The capital is called Canton or Canton in Western language. The Chinese pronunciation of the capital is Guangdong in Mandarin. The speaking population in 2022 estimation is that there are more than 100 million speakers in Guangdong province, more than 7 million speakers in Hong Kong, 700,000 speakers in Macau, and outside of China, there are more than 80 million Cantonese native language speakers, according to Cantonese Language Association. Many models nowadays have been proposed for majority of the popular languages. However, for low-resource language machine translation, it is still a challenge for many researchers. Cantonese translation using machine translation is an underexplored area that needs to deserve more attention from NLP researchers. The objective of this research is to investigate one of the more popular MT methods, such as synthetic data augmentation via back translation and model fine-tuning. The purpose is fine-tune Cantonese to English neural machine translation, introduce this new language pair with open source toolkits and platform. We select several models for evaluation, including both smaller and larger models, and compare their system performance using a range of evaluation metrics, including both lexical similarity metrics and embedding metrics. Finally, we will demo our platform available on GitHub. There are a few related works about Cantonese English machine translation and Mandarin Cantonese machine translation. Also, there are data augmentation via back translation research. We suggest to read our paper for detailed background. Regarding data collections, we used words.hong Kong or 月点. 月 is another word for 月 is an abbreviation about Guangdong province. And then the second one we use is monolingual dataset. We collected from Live HKG forum. It was launched in 2016, and it had multiple categories, including sports, entertainment, hot topic, gossip, current affairs, etc. We extracted 1 million sentences from Live HKG forum and did data cleaning and anonymization. In the end, we have around 200K monolingual data from this forum for synthetic data generation purpose. In our extended work, we found two more data sites. One is called Wenlin ABC Cantonese English Dictionary that has 14.5K parallel sentences, and the Opus Corpus has 10K parallel sentences of Cantonese and English. Here is an example of the text we collected from Live HKG forum. You can see that the profile ID is masked or totally removed from the and URLs and random strings are removed during cleaning. Regarding three models we select, they include the NRV 200, no language left behind from Meta, Opus MT, Chinese English, and BART 50. The selection of these models, we have some rationales. Firstly, we wonder how much does model size impact fine-tuning performances. In this case, Opus MT has only 80 million parameters, while no language left behind 200 has 600 million parameters. Secondly, to what extent does it matter if the pre-trained translation models were exposed to Chinese in their pre-training? In this case, BART 50, which has 600 million parameters too, did not have Cantonese in its pre-training, but NRB and Opus MT have. Regarding the methodology, we can see that, firstly, we use 38K parallel real data, fine-tune, no language left behind. We got a fine-tuned initial model. Use this model, we translate 200K monolingual Cantonese sentence into English. So we got 200K parallel synthetic corpus. With these parallel synthetic corpus, we add with real data with certain ratios to fine-tune large language model again, and then evaluate the further fine-tuned large language model with both lexical and embedding metrics. In the second part, we had the Wenlin and the Opus corpus to add up with the first real parallel corpus from Warsaw to Hong Kong to fine-tune the model, get the model evaluation. That's only trained using real parallel data. We have some learning curves on BART, no language left behind, Opus MT, using blue score with training loss and validation loss. Here is an overall figure of our automatic evaluation where we use the Sacred Blue, H-LIBR. Both of these two are lexicon-based metric. What worth to notice is that H-LIBR is a metric that we proposed ourselves 9 years ago or longer, and it was ranked top 1 in WMT shared task. Birth score and comments are embedding metrics that we use to compensate with lexical metric. In this table, we will see no language left behind a forward model using bilingual real data. No language left behind a forward model using synthetic half-half means half real, half synthetic. 1-1 is 100% real and 100% synthetic. Similarly, 1-3 is 100% real and 300% synthetic. In the second cluster is the model switch. No language left behind is a base model, but trained using the synthetic data from BART, from Opus, respectively. In the third cluster, the base model is BART, but using synthetic data from no language left behind model. Similarly, this cluster is using Opus as base model. Here, 10E is 10 epoch because the default epoch is 3 instead of 10 due to our limited computational resources. We also added comparison to commercial translator, including Baidu from China, Bing from Microsoft, and GPT-4 fine-tuned version, which is called the Cantonese companion by community researchers, community fine-tuned. But pay attention to this that we do not know any transparent parameter or how much data was used or what data was used for Cantonese company. Lastly, we added the new corpus in the second part of investigation using Wenlin. And we also added all three corpus in the end to compare. From the automatic evaluation, our finding is that no language left behind the synthetic with 1-to-1 ratio, 100% real and 100% synthetic has slightly better score than no language left behind using only bilingual real on all metrics. But the increasing ratio of synthetic data will decrease the score, such as if we use 300 or 500% of synthetic data. This might be due to some noise introduced from the synthetic data, so the data quality matters. Similarly, please read our paper for more findings on MBART and OPPOSIT. Regarding model switch, we realized model switch helps or matters because it can give slightly higher automatic evaluation score than without a model switch. Compared to base model without fine-tuning, we can see that the fine-tuned model is much higher than base model across our evaluation metrics. That means our fine-tuning was successful. Regarding GPT-4 fine-tuned Cantonese companion that reached the highest score in our comparison, that is a good news. However, we do not know the transparency of this fine-tuning and the dataset used. Regarding data privacy, we think our Cantonese MT platform can be totally confidential to users. That's people who use CantonMT platform can have their own data fully controlled by themselves. For example, if we translate the sensitive clinical data or patient data, that's our latest published from this year in Digital Healthcare Frontiers on Neuromachine Translation clinical text. In such a situation, CantonMT will be more favored than other commercial platforms. We also have further evaluation using human evaluations, use Hope metric. Please check it out in our extended manuscript. And our open source platform is hosted in this GitHub page. Now let's go to our demo. Here, it's a YouTube public demo that you can check out.
Hi, this is a demo for the CantonMT paper. And what we are doing here, it's an interface demo, which first of all, we got some different models here to choose from NLP, Opus, and MBART. That's the model type that we go for projects. But then it can be expanded to different models too if people use. And for input, we got Cantonese English, so it's both directions for now. But obviously, it can be improved in the future if someone just wants to use it for like different language too. And then based on the model type and then the input here, we will be the system will send like the API request to the servers to find like what models are available on the server. And here it's a local server, and it got like 5 different models. And then let's say we just choose this one because this got the best performance. So we can do the translation easily here. So, and then we will translate. We'll just send a request to the servers, and then we'll get back the API response from here and put it in. And you got the output sentence, and that's it. Thank you. Finally.
Okay, thank you.